From cave wall to billboard, the uniquely human creation called art has celebrated nature's unique creation, the human body. Science, too, has much to tell us about ourselves. Right now, your body is performing amazing feats of engineering, chemistry, and physics that no machine designed by man can duplicate. A close look reveals our evolutionary heritage. Male and female alike, our bodies hold as many hair follicles as our relatives, the chimpanzees. Packed with nerve endings, our lips are among the most sensitive parts of the body. Look closely at lips and tongue and marvel at their versatility. Look closer still at the tip of the tongue magnified 60 times and marvel merely at the sight. Beauty, we say, is in the eye of the beholder. But all we ever see of one another, skin surface and hair, is dead. Our skin is constantly growing from within, creating new cells that push their way outward, then die near the surface. The whole process takes about a month. Weighing about 6 pounds, the skin is the largest single organ of the body. Yet it's only about 1/20th of an inch thick. The ridges of our hands evolved to help us hold on to things. Our fingertips hold 2,000 pores per square inch. This giant cavern is merely a single pore, magnified 2,400 times. The green spheres are bacteria, always present, no matter how often and vigorously we may wash. Some 2 million such caverns cover the body, part of our efficient cooling system. Heavy exercise can raise internal temperature up to 7 degrees above normal. The body dissipates this excess heat through the evaporation of perspiration on the skin. Only 1/4 of the energy we produce by muscular exertion is converted into work. The remaining 3/4 is heat. We usually associate perspiration only with heavy exercise or extreme heat. But even under normal conditions, we perspire constantly, between 1 and 2 pints a day. These bizarre scenes show variations in temperature from one part of the body to another. They're made not by visible light, but by heat, on a machine so sensitive it can record heat left behind by a handprint or a moving finger on a wall. Used medically, as an aid to detect tumors and to diagnose the severity of burns, the thermovision camera converts invisible heat radiation into color video signals. Each color represents a difference of 1 degree Fahrenheit. Blue generally represents coolest temperatures, red or white the warmest. Not only does the skin help cool and protect the body, it also serves as a sense organ. It seems likely that before birth, the fetus receives most sensations through the skin. From the moment of birth, humans seem to require touching and physical affection as much as food.
Oh, what a pretty baby. can be so big when you get older. Yeah. You are, uh-huh.
As the infant grows, it will rely more and more on other senses. We are basically visual creatures, receiving about 90% of all our information through our eyes. We're constantly blinking, once every 2 to 10 seconds, bathing and lubricating our eyes with tears. And someone has calculated that blinking causes our eyes to be closed for half an hour out of each waking day. Our iris can adjust to changes in light intensity up to 1,000-fold. The lens of the eye inverts images projected onto the retina. Exactly how we perceive everything right side up is still not fully understood. Lubricant tears contain an antiseptic agent that helps defend against disease. Many animals produce tears, but as far as we know, only humans weep as a result of emotional stress. The range of human hearing is exceeded in nature by that of many kinds of creatures, but our hearing sensitivity is remarkable. A good ear can discriminate some 1,600 different frequencies. Inside the ear, sound vibrates the eardrum, shown here slowed down 200 times. 3 tiny bones move vibrations along for conversion to electrical impulses and reception by the brain. The tympanic muscle protects the delicate apparatus against excessive noise. Watching the muscle move, we can see the ear hear.
Hello? This is her sister. Oh, I see. Oh, just a minute. Karen, do you know a boy named Walter? Walter. Last name is Brent. Brent, do you remember?
Throughout history, individuals forced to cope with the loss of specific bodily functions have inspired us all with their courage, stamina, and skill.
Okay, just a second. Let me see if she can.
Attempts to repair or replace faulty parts occupy many medical researchers. Almost every day brings new advances in electronics, engineering, and exotic synthetic materials. Through microsurgery and other radical techniques, doctors seek ways to help overcome loss of sight and hearing. This California college student was born deaf. Now she has just had an electronic implantation in her inner ear, a bold new surgical procedure thus far tried on only a handful of patients.
Very faint, she said. Okay. Keep counting.
For the first time, she hears the sound of her own voice. The implant does not provide normal hearing, but in most cases has brought at least a perception of sound where none existed before.
At the keyboard here on KFAC's Commuter Classics, the famed pianist Alfred.
The enormous range of human sounds is the product of an exquisitely complex system. The meaning of speech, the aesthetic of song, can be altered by minute movements involving diaphragm, lungs, windpipe, mouth, nose, tongue, lips, teeth. The actual sound created by the vocal cords alone is simple and faint. A cough. This, slowed down 200 times, is what happens to our vocal cords when we cough, releasing trapped air with explosive force. These wild undulations are but a single cough. In an intricate, life-giving exchange, we take in about a pint of air with each relaxed breath, around 14 each minute. Inside, we work somewhat like a bellows. The diaphragm pulls down, chest wall expands, and air rushes in to fill the partial vacuum. The trachea, or windpipe, splits into two large tubes, the bronchi, one going into each lung. Smaller bronchi branch off into even smaller passages, much like branches and twigs growing off from a tree trunk. The entire gracefully swaying structure is often referred to as the bronchial tree. The tiniest twigs of the tree terminate in the alveoli, 300 million microscopic air sacs which constitute the bulk of lung tissue. Entwined with clusters of alveoli, a network of capillaries, microscopic blood vessels. Air sac and blood vessel lie side by side. Through incredibly thin, transparent membranes, red blood cells snatch up oxygen and surrender waste, carbon dioxide, to be exhaled. Responding to stress, the intertwined systems, respiration and circulation, display remarkable adaptability. Lungs and heart can perform prodigiously, pumping about 10 times the amount of air and blood we need when we're relaxed. The heart's double-barreled pumping action propels blood through the system under great pressure. This is how it sounds, recorded with a tiny microphone inside a living body. Blood, the river of life, journeys endlessly through 60,000 miles of blood vessels. Blood's main function is carried out at the cellular level. Oxygen, water, and nutrients are delivered to each body cell, and waste products are collected. A complete tour out from the heart and back takes less than a minute, from vessels 1 inch in diameter to capillaries and venules so small that blood cells must line up to squeeze through one at a time. At all times, even during the most commonplace of our daily routines, our bodies are the scenes of dramatic action. Facing the threat of invasion by hostile bacteria or other foreign organisms, the body mobilizes for defense. Among its donut-shaped red cells, the bloodstream contains a small, highly mobile strike force. Leukocytes, white cells. Wriggling about under its own power, a leukocyte seeks out, attacks, and consumes a foreign invader. The white blood cells are both warriors and scavengers. In addition to their battlefield duties, they help cleanse the bloodstream of debris. Built of thick and tough muscle, the heart is a marvel of mechanical performance. Beating about 70 times a minute, it pumps 2,000 gallons a day. One-way valves prevent blood flow from backing up. Merely the size of a fist and weighing less than a pound, the heart's dynamo pumps 55 million gallons in a lifetime. No longer regarded as the temple of the soul or the seat of intelligence, the heart and its corridors nonetheless inspire awe and reverence for the beauty and efficiency of nature's design. As science probes ever deeper into the secrets of nature, knowledge takes on an aura of fantasy. We learn, for example, that a single cell of heart muscle continues to beat even when removed from the heart. In another laboratory experiment, 2 heart cells in a culture dish beat individually, each at its own pace. But when they touch, they synchronize and beat in unison. To utilize raw materials that build tissue and supply energy, the human body employs a complex chemical conversion process. Despite frequent abuse, our digestive system routinely performs extraordinary feats of chemistry. Even before the first bite, the mouth prepares by increasing secretion of saliva. Mostly water, saliva helps chewing and swallowing, and contains enzymes that begin the digestive process. Down the gullet, or esophagus, a tube 9 to 10 inches long, less than an inch wide, leading to the stomach. Like most of the digestive tract, the esophagus is lined with muscles that squeeze and relax, pushing food along every step of the way. Walls of the stomach churn the food and mix it with enzymes and acid. In normal digestion, the stomach produces hydrochloric acid, strong enough to burn a hole in a rug, but protects itself with a glistening layer of mucus. In the overall digestive process, the stomach serves largely as a way station. Most of the work takes place in the small intestine. Millions of tiny villi lining the intestine help convert usable nutrients into forms the body can absorb. Total distance traveled between intake and outlet, 30 feet. Total time, 1 day. Despite our wide variety of motion, our muscles can do only one thing: contract. We're painting them red and blue, flexors and extensors, to show their arrangement in opposing pairs. One muscle contracts to pull a bone forward. Its opposite number contracts to pull it back. Forward and back, up and down, the entire range of movement derives from muscles' one-way action. We have, in all, more than 600 muscles, comprising about 40% of body weight. Our bones, amazingly strong and light, make up only 18% of our weight. Healthy joints are lined with a glassy, smooth cartilage and lubricated by a thick fluid said to be so effective that nothing technology has produced can match it. Of the body's 206 bones, more than half are in the hands and feet. In running, legs and feet take up to 5,000 pounds of pressure per square inch. And in some athletic events, like jumping, pressure is estimated at up to 20,000 pounds per square inch. The unique engineering design of the human body reaches its apex in the hand, powerful and precise servant of the mind, creator of civilization and culture. 25 joints give it 58 distinctly different motions and make it the most versatile instrument on Earth. We have barely begun to understand the potential of the human brain, control center of the incredible machine, and the most complex of all living organs. How, for example, to account for hypnosis or the seemingly bizarre feats of exotic Eastern disciplines. Subjects have learned to identify and control different types of electrical waves emanating from the brain. Electrodes, picking up brain electrical activity, are connected to an electroencephalograph, an EEG machine, which in turn regulates flow of current to a toy train. When the brain emits waves of a specific frequency, alpha waves in the case of this subject, the train moves. The larger the alpha waves emitted, the faster it goes. The implications are vast, almost limitless, controlling one's own mind and consciousness, controlling or coping with emotional disturbances. All of these may one day be within man's grasp, and that day may soon be at hand. In the words of Joseph Conrad, the mind of man is capable of anything, because everything is in it, all the past as well as all the future. What a piece of work is a man, wrote Shakespeare. In form, in moving, how express and admirable. In action, how like an angel. The